Hi and welcome. I'm trying to learn particle physics, today muons, and after we're done with, we're gonna do Neckstretching. And if you participate in the Neckstretching, then it's very honest. Why are muons so interesting? The best way to think of a muon is that it is very much like an electron, a particle that is present in all atoms. Okay, in all atoms there are electrons present. And they are pretty similar as electrons, these muons. Muons have all the same properties as electrons, except they are around 200 times heavier. It's actually quite a lot. Normally it would be just a bit more heavier, but 200 times. Okay, they are the same as electrons, but they are heavier. In the 1900s, we're talking of the human physicists and scientists, revolutionized technology by understanding the electron and how to manipulate it. They mean to generate and use electricity. Okay, maybe we're going to do this video. To revolutionize the technology and understanding of the electron and how to manipulate it. So way to express, to generate and use electricity. To make a toast warm. The moon is exciting because it's another particle we could learn to manipulate. Okay, a similar particle to the moon, the electron, are humans able to manipulate in making electricity. That could be useful in terms of technology. Again, or in my field, okay, we're talking from a perspective of Alex Kejabarzi. Alex Keshwazi. It's my best try, Alex Keshwazi. We're having an artistically made photograph. I think it's Alex. I'm going to call him Alex. Okay, Alex. The moon is exciting because it's another particle we could learn to manipulate. That could be useful in terms of technology again, or in my field. So Alex says in his field, particle physics as a way to understand how the universe is put together. Okay, Alex tries to understand how the universe is put together. That's amazing if you understood from that section. We don't find moons just lying around though. Okay, moons are not that easy to find, does he say. A person has something like 30 moons shooting through them at any given moment. Okay, they're not lying around, they're shooting all the time through a person. At any given moment, 30. So they are common, but perhaps not by the standard we're used to. Okay, there are a lot of them. There are 30 of them all the time passing through a person. The thing is, the electron has an infinite lifetime. That is interesting. Has it something to do with energy? That energy cannot be destroyed, or what was it? Electrons have an infinite lifetime. I think should have it maybe as a, maybe it's a little bit passive aggressive, but as a basic idea when we go into batteries. Why do they just by nothing release their charge? Why do batteries lose charge? We have the fundamental principles that electrons have an infinite lifetime. The answer has nothing to do with the electrons having a lifetime, but maybe that's an interesting way to approach it with a new energy to find a solution to make better batteries. But muons live for only 1/500,000th of a second. Now where do we come then all from? Where do we come now all from? Because if there are 30 passing through a human being at any given moment, how fast are they? If they are very slowly, it could mean there are just 30 in space. If they're very fast through, it would mean there are way more. However, if there are 30 of them, and they only have a lifetime of 1/500,000th of a second, they have to be created all the time. The reason they are so widely studied is that, thanks to their mass, they have more energy, and so they should interact more strongly with other heavy particles that might be out there. They have more energy. More energy, maybe we could actually make some use of trying to understand and manipulate these muons to have, what do we call it? Moonality. To make our lamps burn. Okay. They have more mass and more energy, and that means they are interacting more strongly with other heavy particles. They are a useful tool because they might help us get a glimpse of other particles that we couldn't see via electrons. There could be more particles. We are searching for some. That we already told us in particle physics. We don't understand why we have different sizes, and there's possibly a lepton quark that is half a lepton, half a quark, and has an influence on them, or whatever it was. It's a hypothetical idea. Now, and with electrons to find other particles is not that easy because we don't interact that much with them. But if we understand the muon, we can easily find other particles because the muon is interacting stronger with other ones. If you're looking for fallen down wooden, I don't know what we call it, for something out of wood, we can't find it with a magnet. But if we have something out of iron fallen down, we can just find it with a magnet very easily because the magnet is pulling it towards it. Or if people are, I think you understand the example. How do we get a muon to hang around long enough to study it? Now that's the question. One of the tricks is to speed it up, which gives it more energy. Okay, we could speed the muon up and then it has more energy and then it doesn't decay as fast anymore. Is it a rule? Let's just think for one little second. Imagine if it is a rule that things are staying longer stable or existing longer or decaying slowly if they have more energy. No, maybe that's very useful for someone. One of the tricks is to speed it up, which gives the muon more energy. Special relativity kicks in and you get a time dilation effect, like you see at the edge of a black hole. At muon G2, we speed the particles up so they have a lot more energy, taking the lifetime from 2 microseconds to 60 microseconds. It's still just a blink. But 60 microseconds, so we made our muon from 2 microseconds to 60 microseconds, but it's still a problem. If muons exist still just 60 microseconds, even if they're longer, and electrons are infinite energy, we can't really use them then as electricity if they just decay, even if you get it more stable. But what if they're much faster? And it isn't necessary that we store the electricity so long in muons. We just send it through a cable to the burning lamp or to the toasting toaster. We're making the toaster toasty. And it doesn't matter if the muon doesn't exist that long. So whatever. That was the particle physics part. If you were here for particle physics, you can go directly to the next part of particle physics. We will do now the Neckstretching. If you stay and participate in the Neckstretching, then it's better if you always go. Good in 7 cents. And we're doing the hydro tower. We are breathing in it. We are stretching with the fingers as far as we can. Breathe in and stretch as far as you can with the fingertips. And again, down, stretch as far as you can. And down. And another time, stretch as far as you can with the fingertips. Breathe in, reach high, stretch as far as you can with the fingertips. And stretch again as far as you can. Down. Next exercise. Arms in front, big circle. And again, stretch as far as you can with the fingertips. And not just to the side, but also back. Stretch as far as you can with the fingertips. And down again. And reach and stretch. And stretch still. And also back and down. Now let's continue with testing this exercise out if it brings something. Bullseye. Feet are standing together, arms up to a T. And pretend to be a bullseye fly. Now the police officer. Feet are standing together, pretend to the arms up. And breathe out of the arms down to one side. Again in the arms up. And out of the arms to the other side. Again in the arms up. And out and down. Now the clap in the morning. Feet are standing together. Breathe in with the arms up. No, we don't do it together. We're having the legs standing shoulder with wide apart. And we're breathing in. Shoulders back. And out, tall up. And to bring the head over to one side. Breathe again in. And out and bring the chin down to the clap. Breathe again in. Lift the chin off your face. Out and turn the head over to the other side. Tall up, shoulders back. Breathe again in. And out and bring the shoulder down to the clap. Chin down to the clap. Again in the shoulder. And now again, turn up, shoulders back, breathe in. And out, head over to one side. And breathe again in. And breathe halfway out. And bring the head in circulatory movement over to the other side. Breathe again in. And out, bring the head over to the other side. And back in the middle. Now we're doing the breath. The feet are standing together, we're breathing and lifting the arms up. And breathe out, lean back, draw the shoulder blades together. Again, in the arms up. And out the arms down, draw the shoulder blades together. Again, in the arms up. Bring your hands to touch and lean back, read in the wind. Breathe again in into the middle. And out and lean back. Breathe in into the middle. And breathe out, go over to one side. Breathe again in. And out over to the other side. Breathe again in. And out the arms down. Let's do a screw. Breathe in, lift the arms up. Over cross the arms, intertwine the fingers and reach high. Breathe in, reach high. Breathe out the arms down. Over cross the arms the other way around, intertwine the fingers. Interlace the fingers. Breathe in, reach high. And breathe out. And down. Let's do the drill. Breathe in the arms up. Over cross the arms, intertwine the fingers, reach high. And breathe out, reach in front, hold on the back. Again, in the arms up. Over cross the other way around, breathe in and reach high. And breathe out, reach in front, hold on the back. Again, in the arms up. And out and down. And let's try an exercise. The arms together, also with the elbows, hands and elbows together. Turn up, and now lift the arms higher. If the arms and elbows are staying together. Try to relax the arms and the shoulders. And again down. And let's do it another time. Elbows are staying together and bring the arms up. And again down. Next exercise, the cashew. The feet are standing together. Interlace. The fingers behind the back. Breathe in, turn up, shoulders back. And breathe out and bring the head over to one side. And the chin down to the back. Breathe again in. And out and pull the hands down to the ground. Again, lift the gaze. Breathe out, bring the head out to the other side, shoulders back, turn up, breathe again in. And out, bring the chin down to the clavicle. And pull the hands down to the ground. Again, head up, back in the middle. And the stretch of the hands. Leg shoulder width wide apart, intertwine the fingers again, hand the back, bring them out to one side, turn up, shoulders back, breathe in. And out, turn the head to the side where the hands are. And bring the chin down to the ground. Breathe again in. And out, pull the arm in and the shoulder down. Breathe again. Lift the gaze and turn the head over to the other side. Also the hands over to the side. Turn up, shoulders back. Breathe again in. And out, pull, or bring the chin down to the clavicle. And pull the arm in and the shoulder down. Again in, lift the gaze. And back into the middle. And now, the sky hugger. Feet are standing together, breathe in, lift the arms up. And breathe out, lean back, long arms. Again in. And out and lean back. Breathe again in. Arms down. Let's do 2 eagle's wings. Breathe in, lift the arms up. And breathe again out. Again, the arms up. Out. And the last movement, the cactus connecting its stings. Breathe in, lift the arms up. Bring the hands to touch and lower the hands down to heart center. That was the neck stretching. I thank you very much and until next time.